Let's start our notes over day 2 of graphing the sine and cosine functions. Today we're going to dive into horizontal transformations. So again, I just want to go over. Here we have our sine parent function over here. Here we have what we can refer to when we look at our transformations of the sine function. We have our amplitude changes. These are going to be our period changes. Inside the parentheses, we're going to have our horizontal translations, which we'll definitely look at today, and then we have our vertical translations. So yesterday we changed our amplitude and we looked at vertical translations. Today we're going to focus on those period changes, which can be more difficult to graph, and then the phase shifts or the horizontal translations, which really make you think. Again, the sine function, we start at our middle point, and it takes this shape right here, mid, high, mid, low, mid. Our cosine function starts up top, and it goes high, mid, low, mid, high, okay? It looks just like that. So here we have our cosine function. We're also going to talk about frequency today. Frequency is the number of cycles the function completes in a given interval. An interval is generally 360 degrees or 2 pi, or, like all the way around the circle. The frequency is the value of b. So I can just see when I'm looking at an equation, I can see the value of b, and that is the frequency. So for example, if I have a cycle or a period that's pi, okay, that's terrible, pi. Let's say I have a period that is pi, right? So that's the length of one cycle. So that's the length of one like sine, right? Let's just say. Well, how many of those can be completed within the length of 2 pi? Well, I have another one, right? I can do another one, which I totally did a backwards sine function. So let's say I do that, right? I can have another one to get to 2 pi. So what's my frequency? It's 2. How many of those cycles can I fit within an interval that's generally 2 pi or 360 degrees? So that's what frequency is. So period is the length of the cycle, and frequency is the number of cycles in an interval. So let's look at this first one. It says state the amplitude, period, vertical and horizontal translation, and frequency for each function. So and horizontal translate and frequency, I need to fix that. Then graph. So I have y equals sine of theta plus 270 degrees. So in this case, I only have one thing that I'm looking at. It's inside of the parentheses, which is a horizontal translation. So recall, just like in all the other functions that we looked at, or that we've talked about this year, that plus 270, if it's a horizontal shift, I'm moving right or left. Plus 270, which way am I moving? I'm moving to the left. So I'm going to be moving to the left 270 degrees, and that's where I'm going to start my my graph of sine. And I like to graph one cycle to the right and one cycle to the left of that kind of center line. In this case, we don't have any amplitude changes, so it's still 1. We don't have any period changes. That would be something that's like in front of that theta. We don't have any of that, so it's going to be the same period as our parent function, which, because we're dealing with degrees, one period is 360 degrees. We don't have a vertical translation, and in this case, we added frequency in today's lesson. It's the number like in between sine and, theta or x. And in this case, there's nothing there, which means your frequency is 1. Okay, so there's only going to be one cycle in our interval of 360 degrees. So the first thing that I really want you to do is, we're going to talk about like our little tick marks, right? So yesterday we had an interval. We started at our center point, our center line right here, which was always the y-axis. And we went out, okay, I have a period of 360. We divided it up into fourths, and then we said, okay, 1/4 is 90, 180, 270, and so on. Okay, so in this case, we're going to be dividing it up in using those same values, right? We're going to be counting by 90 degrees. So that's really important to first notice. You know, we're not moving up or down, so we still have our midline here. 1 we still have as our high line, and -1 we have as our low line. And what I'm going to do is I'm going to count by 90s. And it's not really going to be difficult for this problem because we're only moving left 270 degrees, and we're going to fit it in on this graph. Sometimes it's easier if I'm just like graphing on like a notebook paper or something, right? So I can kind of draw my own little graph. But this time the graph is like given for us right here. So we kind of have to work with that, make sure we can fit everything in. So I'm going to count by 90s, and I'm going to go -90 degrees, -180 degrees, -270 degrees, and that is where I'm shifting this whole function. That's like my new, and that's a really terrible line. Oh my gosh. That's like my new y-axis, if you will. Okay? That's like my new y-axis. And I'm going to keep counting by 90 degrees. So this is going to be -360. This is going to be -450. This is going to be -540. And this is going to be -630. Right? And I'm just adding -90 each time. So the reason I like to do that, okay, and I'm going to have a 90 degrees right here, is from that center line that we shifted to, I still want to go out, you know, I've got one cycle, right? So I've got -270. If I add 360 to that, I'm at 90. Okay, so -270 plus 360 is 90. -270 minus 360 is -630. Okay, so that's where our graphs are going to end. Okay, that's where I'm choosing for them to end on here. So when I go out to 90 right here, I've got my 3 tick marks, right? And there's 0 degrees. And then what are those values? I'm counting by 90 degrees. And then when I go out to my -630, that's where I'm at over here. And then I've got my 3 tick marks because I'm dividing it up into fourths from that center point. And then I'm putting my values on there. So again, just like in yesterday's lesson, that's really important for graphing sine and cosine, is making sure you get your labels correct. So now, which graph am I graphing? I'm graphing the sine function. So I'm going to start at my center point, which is right here. We shifted over 270 degrees to the left, but we didn't move up or down any. We don't have any reflections. And so we're starting at that center point, and it's going to take that same shape of, again, you can draw that. We're going to go at -180, which is the little tick marks that I drew. I'm going to go up to 1. Then I'm going to come back to the middle, down to the low, back to the middle. And because I plotted my tick marks and my interval, everything correctly, then I'm just moving over and I'm following the pattern, right? Mid-high, mid-low, mid. And I'm going to go one cycle over to the right of that like phase shift, because that's what's kind of important in today's lesson. And then I'm going to go one cycle over to the left of that phase shift. So at -360, I'm back down to 1. So low, then mid, then high, then mid. And so it's following that same pattern. But it's all about making sure you understand, you know, your phase shift. So what does this look like, right? This sine function, honestly, right here, it kind of looks like the cosinusoidal function reflected across the x-axis, right? So, you know, they look very similar. It's just all about how you plot, okay? So let's move on to example number 2. Whoa, is this gonna, okay. All right, so in example number 2, we don't have any horizontal translations, okay? Nothing in parentheses. We don't have any vertical translations, no constant added or subtracted. We don't have any amplitude changes, but we do have a number in front of our x. That number in front of the x is going to change the period. It is the frequency, okay? So first, let's kind of go through this. Amplitude is 1, just like the sine parent function. We'll get back to the period. I'll show you how to do that. There's no vertical translation. There's no horizontal translation. The frequency is this value of 2. That is the frequency. And remember, the frequency is the number of cycles the function completes in a given interval. An interval is generally 2 pi. Okay, well, what's the period for this particular function? The period can be found by 2 pi divided by that number right there, that b value. So 2 pi divided by b, or 360 divided by b, that's the period. And this is on your notes on the other page. So it's 2 pi divided by b, or 360 divided by b. Because we've got a variable of x, we're going to use radians. 2 pi divided by 2 is pi. That means one period, the length of one cycle is pi. Well, if the length of one cycle is pi, how many of those, like that pattern, can fit in 2 pi? 2 of them. Okay, so we don't have any horizontal shifts. We don't have any vertical shifts. So we're going to start, because this is a sine function, at 0, 0, thankfully, right? Because we've got a period change. My period is pi. I'm going to go out here and do pi. I'm going to go out here and do negative pi. And again, if you want to go all the way out to the end and, you know, use all that, that's fine, right? Just get your points plotted correct. Get your labels on your axes labeled correctly. So if that's pi, I'm going to draw 3 tick marks dividing that up into fourths. What is that? If I'm taking pi and I'm dividing it into fourths, each one of those tick marks represents a fourth. So this is pi over 4. This is 2 pi over 4, which is pi over 2. This is 3 pi over 4. And these are going to be my negative radians. Negative pi over 2 and negative 3 pi over 4. We don't have any amplitude changes, so my high point is 1, low point is -1, or low line's at -1. And because we've got everything graphed on here, or shown on here, labeled correctly, now I can go ahead and graph it. I'm at 0, 0. Remember, the sine function does this right here. So 1 over, I'm going to go high. I'm back to the mid. Then I'm going to go low. Then I'm going to go mid. And it looks just like this. And I'm just graphing one cycle from like that center point. We don't have any phase shifts, so I don't really have to show that where I did on the previous example, but we do have a period change. And then over this way to the left of that y-axis, I'm going to go low, then mid, then high, then mid. And so it just takes that same pattern. And then in this case, our range is still -1 to 1. Our domain is still -infinity to positive infinity, right? This is just a periodic function. It's just going to repeat in this exact same manner. Thankfully, no vertical translation, no horizontal translation, but there was a period change and a frequency change. Like, remember, one, interval is generally 2 pi. That's out here. All right, well, this could fit a whole nother one in there. How many of those could fit in that one interval? 2 of them. That's the frequency, okay? Let's move on to example number 3. Okay, in example number 3, we've got a little more going on. We do not have an amplitude change, which means what's the amplitude? It's just 1, right? Distance from your midline to your high line. We don't have a vertical change. So that means my midline is right here, right? It's just the x-axis. However, we do have a period change. This value right here is our b value. What does our b value represent? Period or frequency? It's the frequency. It's 2. How do we find the period from that value? We take 2 pi, and we divide it by that b value, which is just pi. So our period is the same as the previous example. In our previous example, I'm going to kind of go back up to it. We had to, our one period was pi, that's the length of one cycle, and we counted by fourths, right, to get there. So that's what I want, that's how we're going to be labeling our whole x-axis, is by fourths, okay, or pi over 4, if you will. And we do have a horizontal translation for this one. In this case, our horizontal translation is inside the parentheses, it's pi over 2. Do we move left or right? We move left pi over 2. Remember, and that's like 90 degrees, right? So my period is pi. I'm counting by fourths. I'm going to go ahead and label pi right here. And I'm going to count by fourths. Pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. Okay? Which means over on the left over here, if this would be negative pi, I'm going to split it up into, oh my gosh, this is terrible. That was terrible. I need to go out a little bit further. Use a pencil. Use a pencil for sure. Oh my gosh, I did it again. Okay, I'm just going to do this. Oh my gosh. All right, so there's negative pi over 4. There's negative pi over 2. There's negative 3 pi over 4. Golly. Sorry about that. Okay, so I've got this labeled. I know my amplitude is 1 and negative 1. So if you need to pause the video to kind of catch up with what I've labeled, go ahead and do that. Because we have a phase shift, we're moving over to the left, negative pi over 2. This is becoming like my new y-axis, if you will, okay? So there's my new starting point, and I need to graph like that means I'm going to need to add 2 more tick marks here, okay? Because I want to graph a full cycle to the left of that phase shift and a full cycle to the right of that phase shift. And I mean, it's a periodic function, it's a wave function, it's going to repeat the same pattern, but I think that's a good general strategy, you know, rule whenever you're just starting to graph sine and cosine functions. So what would this be if I'm counting by fourths? That's negative 4 pi over 4. This is negative 5 pi over 4. This is negative 6 pi over 4, which simplifies to negative 3 pi over 2. So if I'm just counting by fourths, if you will, and then simplifying those fractions, right? 2 pi over 4 is 1/2. 4 pi over 4 is 1, right? 6 pi over 4 is 3 over 2. Stuff like that, then that can really help you label your coordinates on your x-axis. Okay, so now let's graph. This is a cosine function, cosinusoidal function, which means we're starting high, mid-low, and then mid-high. Okay, it looks like that. So that means from our center line now, we're now at negative pi over 2. I'm starting high up here. And because I've labeled everything correctly, I'm going to go mid, then low, then mid, then high. And that is one cycle for this cosine function. Okay, and as you can see, the period is from the top of this, the high line right here, the high point right there, to the high point right there. That's one period, and the length of that is pi. One period is pi. From negative pi over 2 all the way to pi over 2, that's 1 pi, okay? And now I'm going to graph to the left of that line. So I'm going to go mid, then low down here, then mid, then high. And that looks just like that. Okay. Oh gosh, it's kind of it's not supposed to come up to a point like that, but you know, I'm kind of terrible at just graphing these like this. Whoop. Okay. So there's my function. All right. And let's move on to our last and final example in today's lesson. And, you know, sometimes you might see this like 1/2, like in this particular equation, you might see this 1/2 inside the parentheses, outside the parentheses. It's going to do the same thing. It's still the frequency. Okay, so y equals cosine 1/2 theta plus 2. The first thing I want to talk about is the amplitude. What's the amplitude? There's no number out in front, which means it's just 1. So we're going up to 1 and down to -1. Okay? Well, actually, no. Sorry. We're not going up to 1 and down to -1 because we have a plus 2 out here. What is that going to do? That's going to move our entire graph up 2 units. So let's look at this first. If I have an amplitude of 1 and I'm moving the entire graph up 2 units, that means, like, because I've got this already drawn, this like grid right here, you know, a better grid might look like this, because I'm not going below that x-axis. Okay, everything is going to be above that x-axis. So I know that I'm going to go up to 3. 3, 2, 1, because I moved up to 2. That 2 is now my midline. It's like my new x-axis, if you will. Okay, that's my new midline right here. So now let's talk about the horizontal translation. Is there a horizontal translation? Thankfully, no, there's not, because that can be kind of confusing when we've got a little bit more going on. There's no horizontal translation, so our center point, vertical line is just going to stay the y-axis. Now let's talk about the frequency and the period. The frequency is the value of b. The value of b is 1/2, so the frequency is 1/2. What does that mean? In the interval of 2 pi, or 360 degrees, only half of this cycle is going to make it within that 360 degrees. Okay? So the period in this case, how do I find the period? I take 360 degrees and I divide it by 1/2, which is the same thing as multiplying by 2, which is 720 degrees. So one period in this case is 720 degrees. So how am I going to label that? Well, I'm going to go all the way out to here, and that's 720 degrees, and I'm going to go all the way out to here, and that's 720 degrees, negative 720 degrees, and then I'm going to take 720 degrees, and I'm going to divide it by 4, and I get 180, which means I'm going to draw 3 tick marks, right? So I've got my four lines on either side of this, okay? And I'm counting by 180 degrees. So that's 180 degrees. That's 360 degrees. That's 540 degrees. And that's 720. And then we're going to go the other way. Negative 180 degrees. Negative 360 degrees. Negative 540 degrees. So now we've got everything labeled here. Okay, I know that one period is 720 degrees. I know it's a cosinusoidal function that's been shifted 2 units up. And then from that midline, I start, you know, it takes this shape, it has that pattern right there. So from that midline, I start high, which is at 3. And then I go mid, and then I go low. At 540 degrees, my next tick mark over, I go back to mid, and then the last one, I go up to the high. And that is what one cycle looks like, okay? That's what one cycle looks like, or the length of that cycle is 720 degrees. That is what one cycle looks like, okay? And now we're going to go back the other way, so to the left of that, like, center Y vertical line. I'm going to go down to 180, low, mid, and then high. And we're going to graph it. So, you know, what I say is make sure you have, you know, your period in there, right? Your period in there, divide by 4 so you can see how you're counting, right? With your tick marks, how you're counting. You know, then look at your phase shifts and, you know, your vertical translations, your midline, high line, low line. amplitude, all that kind of stuff. You kind of have, there's a bunch of things you have to think about at once whenever you're graphing these sine and cosine functions. And then always just remember, your sine function is going to be like this, and your cosine is just like that, right? The pattern is the pattern, just you start at different points. Okay. And that concludes your day 2 notes over graphing sine and cosine functions. I hope it was helpful.